Unicode, UTF-8 are reading and writing to files in Python. I'm having some brain failure in understanding reading and writing text to a file, Python 2.4. Ucapit \xe1n, capit \xc3 \xa1n. So I type in capit \xc3 \xa1n into my favorite editor, in file F2. Then, what am I not understanding here? Clearly there is some vital bit of magic, or good sense, that I'm missing. What does one type into text files to get proper conversions? What I'm truly failing to grok here is what the point of the UTF-8 representation is, if you can't actually get Python to recognize it when it comes from outside. Maybe I should just JSON dump the string and use that instead, since that has an ASCIIable representation. More to the point, is there an ASCII representation of this Unicode object that Python will recognize and decode when coming in from a file? If so, how do I get it?
Rather than mess with .encode and .decode, specify the encoding when opening the file. The IO module, added in Python 2.6, provides an io.open function, which allows specifying the file's encoding. Supposing the file is encoded in UTF-8, we can use then f.read returns a decoded Unicode object. In 3.x, the io.open function is an alias for the built-in open function, which supports the encoding argument. It does not in 2.x. We can also use open from the codex standard library module. Note, however, that this can cause problems when mixing read and read line.
In the notation ucapit \xe1n \n should be just capit \xe1n n in 3.x, and must be in 3.0 and 3.1. The \xe1 represents just one character. \x is an escape sequence, indicating that E1 is in hexadecimal. Writing capit \xe3 \xa1n into the file in a text editor means that it actually contains \xe3 \xa1. Those are 8 bytes and the code reads them all. We can see this by displaying the result. Instead, just input characters like I in the editor, which should then handle the conversion to UTF-8 and save it. In 2.x, a string that actually contains these \escape sequences can be decoded using the string_escape codec. The result is a str that is encoded in UTF-8 where the accented character is represented by the 2 bytes that were written \xc3 \xa1 in the original string. To get a Unicode result, decode again with UTF-8. In 3.x, the string_escape codec is replaced with Unicode_escape, and it is strictly enforced that we can only encode from str to bytes, and decode from bytes to str. Unicode_escape needs to start with the bytes in order to process the escape sequences. The other way around, it adds them, and then it will treat the resulting \xc3 and \xa1 as character escapes rather than byte escapes. As a result, we have to do a bit more work.
Now all you need in Python 3 is open, file name, r, encoding is equal to UTF-8. Edit on 10th February 2016 for requested clarification. Python 3 added the encoding parameter to its open function. The following information about the open function is gathered from here, this URL. Encoding is the name of the encoding used to decode or encode the file. This should only be used in text mode. The default encoding is platform dependent, whatever local.getPreferred encoding returns, but any text encoding supported by Python can be used. See the codecs module for the list of supported encodings. So by adding encoding is equal to UTF-8 as a parameter to the open function, the file reading and writing is all done as UTF-8, which is also now the default encoding of everything done in Python.
This works for reading a file with UTF-8 encoding in Python 3.2.
So, I found a solution for what I'm looking for, which is there are some unusual codecs that are useful here. This particular reading allows one to take UTF-8 representations from within Python, copy them into an ASCII file, and have them be read into Unicode. Under the string escape decode, the slashes won't be doubled. This allows for the sort of round trip that I was imagining.
If you want to support the channel, please consider liking and subscribing.